In example 5, we're looking at a rotating wheel, and we're showing the graph of the angular velocity on the vertical axis versus time on the horizontal axis. We're asked to describe the motion and draw the graph of the angular acceleration versus time. So remember, omega, which is measured in radians per second, time, which is measured in seconds, you can see that it's starting initially at time 0, initial angular velocity of 0, which means the object starts from rest. And then it starts to increase in angular velocity for the first maybe second. And then once it reaches that preferred angular velocity, it just continues to move at a constant rotational speed until it gets to the last second, which then it suddenly starts to slow down, and at the end it's now at rest. Okay, so that's the description of its motion. Let's go into the graph. Well, to solve for the graph, the angular acceleration is based on the fact that the angular acceleration is the change of the angular velocity over the change in time, which essentially means it's the slope of the omega versus t graph. So if we take the slope of the graph at different places, like here and here and here, then we'll be able to plot the angular acceleration versus time. So I put an axis down here. Over here is time, and then on the vertical axis we're going to have angular acceleration, which is measured in radians per second squared. And so you can see that it goes up a rise of 3 units here over this 1 unit. So I'm going to simply show the angular acceleration is constant and positive during this first second. So we're going to draw a horizontal line here for the first second. And then during this first all the way down to here, that's 1, 2, 3, 4, 5, 6 seconds. So 1 to 6 seconds. For the next 5 seconds, we're going to be drawing a horizontal line right across here until we get till the last second here. And then during the last second, it now has a constant negative acceleration. And so it's going to be exactly the same amount as before, and it's just like that. And if you wish, you can put in some dashed vertical lines. It's not necessary, but there it is during those transitions right in there. So notice during the first second, we have a constant positive acceleration. And it's during the last second, we have a constant negative acceleration. And then during here, it has 0 acceleration, or constant velocity, angular velocity is. And that's it for example number 5.